Good afternoon. I think most of you have met me by now. My name is Dor Abramson, professor here at the Faculty of Grant School of Education. My honor and delight to introduce Dr. Nigel Calder. Dr. Nigel Calder is an associate professor at the University of Waikato, did I pronounce correctly?
That's right, well done.
in Hamilton, New Zealand, which is just under 2 hours drive south of Auckland on Highway 1.
Yeah.
A good day. In his research, Professor Calder asks big questions about what digital technologies have been doing, and perhaps better, could be doing for STEM education. He's been pursuing these big questions in the context of studying the use of digital applications, apps, in mathematics, teaching, and learning. Nigel is a prolific writer. He published a book titled Processing Mathematics Through Digital Technologies, the Primary Years, and has co-edited a number of special issues coming out of international symposia. Recently, my lab has had the sheer pleasure of interacting with Nigel around a chapter we wrote about our own project for a book that Nigel co-edited with, for Springer with Natalie Sinclair and Liz Larkin called Using Mobile Technologies in the Learning of Mathematics. It's just come out, and Nigel promised me I'll get my own copy soon.
Yeah, I'll leave you that one otherwise.
Hostage. Earlier today I was chatting with Nigel about socio-material assemblages and what a dynamical systems approach could potentially afford that conversation. I also learned that Nigel is an avid hiker, tennis player, and a surfer, and that he's thoroughly pleased with all the tourism that the Lord of the Rings has brought to New Zealand. But before you go, you should consult with Nigel about the best season to visit Mount Doom, which some uninformed locals still insist on calling Mount Ngauruhoe. There we go. So please join me in welcoming Dr. Nigel Calder, who will be speaking to us about using mobile technologies to enhance the learning of mathematics.
Thank you and welcome. It's a pleasure to be here, and I'm really enjoying the campus. It's an exciting place to walk around in your new buildings. I've got to make sure I hop in the right lift, of course, so that's a challenge, but I can see the efficiencies are going to come with that. We're going the other way. I look out there and it's a bluebird day, a beautiful blue sky, and I had a little clip sent from my daughter yesterday morning. She's in the south of the South Island, in a place called Queenstown. She lives there, and she had a clip of it snowing actually the day before yesterday, so it's warmer up in the North Island, but she said it was actually so cold down there, even the lawyers had their hands in their own pockets, so it was a bit of a worry for that area, that part of the town. But this is, as it says, that's our main campus, and this is where I live on the coast, so we've got two campuses. This is a boutique, I guess, satellite campus it has been, but we're getting a new building next year, and so I've been asking some questions about this. It's similar in design and flexible learning spaces, and a lot of our schools now have what we call innovative learning environments, so we're trying to replicate that in our practice as well. So, if any of you are ever out there, make sure through Dor that you contact. Would always welcome people to come and visit, but also to come and find a space with hot desks and things like that. So, just to situate where I am, I guess. So a little bit of an overview of what I'm going to talk about today. Some of these ideas you'll be familiar with, but I want to look at them maybe from a slightly fresh way. The affordances, learning processes and influences on those. A couple of the research projects, one in particular that we've just finished with using apps. This idea Dor gestured toward, if you like, the social material assemblages. That's something that we're working on and teasing out. Then some effective apps. That's why I was trying to get this sort of iPad laptop thing going up here while we took a little bit of time. And then some real life context. So how the nature of learning and maths might change. So what does that open up? Okay, it's a key thing. So digital technologies in New Zealand, I guess the DTs we sometimes call them for short, and you get abbreviated down. In New Zealand, the DTs is also about getting the shakes. So I don't know if that's here, but we get a lot of teachers who get a little bit nervous, mainly because they don't have time. It's part of the way they learn, but they don't have time to actually engage with the material. It's a fast-moving world, so things are changing. As researchers, we're trying to I work with teachers in schools all the time, and so we're trying to keep up with them, support them, and find ways of changing their practice within that. But within that, the video technologies, of course, virtual reality technologies. We're exploring some areas around that. I'm just started a paper with Alison Clark-Wilson, who's at the London Knowledge Lab at UCL in London, and they're doing some really interesting work. They're getting, at the moment, got a project, they're getting up to 280 businesses, local businesses, or in London, local, I guess it's not, it could be in London and not be local, who are developing apps and digital technology applications and software and hardware, virtual reality hardware, etc. But they don't have an education focus in it. So they've come to UCL and they're trying to find out where do we input the information. So we've got some really nice, looks like it'll be good for education, but it's that the basic design principle, you've got to have all the users in at the beginning to actually make sense of things. So that's an idea that's exploring quite usefully at the moment. E-learning technologies have been around for a while. We've always had a mixture of Isolation New Zealand, a mix of blended learning and flipped classrooms, but always had an e-learning focus underpinning it. Mobile technologies, which is I'll talk mainly about, and the OTTs, the other technologies. And I think in the book, actually, in the in introduction, I just sort of allude to the fact that, what will things be like? We're really at the beginning of a sort of a transition. What will things be like in 5 years? What will they be like in 10 years? Like if you think with the printing press, the way things unfolded, these technological changes, and I'm not saying we throw everything out and change everything, I'm just saying they influence the way that we might work. Okay, so I think there's the key questions. In what ways might mobile technologies influence the learning? And what might the learning experience, how might it be different? So we need to think, how might it change it? What opportunities does it give us? But I think allied to that is the thought, well, what gets lost? Okay, so I've got one of a PhD student I'm working with is using virtual reality with early years students. Okay, so this is not saying everything's going to be done with virtual reality in that area. What it's saying, what does that open up to? How can you take kids into different worlds? How can you show them things which wouldn't otherwise be possible through immersion? Still, you still need young kids like that, conversing, talking, getting dressed up in drama, so that's where those things, it's not taking away the other important learning experiences in the language. What it's doing is opening up different opportunities. Okay, so this brings us to affordance, I guess, and as I say, you'll be probably familiar with this. It's that complementarity of the animal and the environment, and Gibson was a psychologist, actually coined this phrase this back in '79, so it's not old, but one of the things I like about that is, and Celia Hoyles talks about this too, around the digital media influencing the user, but the user also influencing the digital media. So it's a symbiotic relationship. These things aren't one-way traffic. So in terms of that, this relationship in affordances, he often talked about water. So his example with water was, we take the same water, same H2O, it's the same thing. Maybe these days it's got a little bit of other bits and pieces in it there that unexpected or not supposed to be. But if we take that basic water, the affordances of that water for someone who's in a desert and dying of thirst, a difference to the affordance of a person who's drowning in a stream with that same water, aren't they? So that's where that changes, it's that complementarity. And also for a fish, then that relationship is different again, isn't it? Okay, so that's the way the affordance works, if you like. The other thing around that, and it's a common term in language now, but that's coming back to its key principles. The other thing around that is we sometimes forget, or I see in writing, affordance has been about the positive things, the opportunities, but it's also about the constraints. So as I said before, that question, what are the things that get lost by using mobile technologies? We need to think about these things critically. They definitely open up really good opportunities in mass education, but in all education, and it's part of our world anyway. So, we ignore them at our own cost. But we need to run a critical view over these things. Okay, so one thing they do, and affordance, which has been around for a long time, and we just talked about that, Jim, looking those things with a spreadsheet and having the digital version, the visual version, and then the numerical version, and moving seamlessly between them. So multi-representations have been around for a while, and just a very quick aspect of that is we can show different types of data very quickly and compare and look between them very easily. But it also quite importantly, opens up multi-representations which can be dynamic, and I think the dynamicism of this is an important thing. So this is Tinkerplots. You probably know Tinkerplots in some form or other. It's a exploratory data analysis tool. So this is actually a group of students in New Zealand. It was put in a few years back, so they're 11 and 12 year olds. So some of the things are a little bit maybe out of date, but it's still useful to explore. So here we've got a group of students, and one of the things we often used to do, like in data analysis, was to look at different things, and this is a real common one you're probably aware of, is foot length, comparing foot length to height. So, the kids can very, very easily just pull that out, and then they've got a scale for their the foot length, and then they can go to height. So I posed them a question for this. Is there a relationship between the foot length and height? So, then they can draw that out and get that to a scale. Just nice and easy, just dynamic, very easily. And you can see the different representations here now, but it's dynamic now. But then I reckon some of the interesting questions around this is, okay, who's this person? What does that mean? What about these outliers? What does that mean? So you can pose some questions, but the kids are also posing their own questions, aren't they? Straight away they can be thinking, now I've also got all these things here. So, what does that mean? Is there anything else that I'd like to explore? Is there between about gender and foot length? Is there something around age and cell phone use? So they can pose their own questions, chuck things in, have a play with it, and explore their questions. So that's the power of it. The other one, which I think this was a group of 11-year-olds that asked this question, was around cell phone use. So again, I'm saying this is a little bit dated, but let's just swirl that up a little bit so we can just restart that again. But you can then pull out, here, so it's just more of a two fields there. So, that's quite surprising now. I think that's changed quite a bit even in New Zealand. I'm sure it's changed here in California. Cell phone use for, 11 and 12-year-olds, no, yes. You could say, well, definitely there's more no. But what does that mean in terms maybe around regions? So one of the kids asked, well, what about Auckland? That's the biggest city. They're pretty slick and sophisticated. They must have much more cell phone use there. So, again, they can just pull that out and play with it and have a look. Now, does that mean anything? Maybe, maybe not. Maybe I need to explore to see if there's numbers there. What does it mean in terms of some descriptive statistics? So that's not really telling me a lot, but I can look at the ratios maybe. But within that, I can then very easily explore. So, okay, well, let's just see in terms of percentage. Oh, okay, so now they are, given, I guess, some elements there, they're in a closer sort of a ballpark. So within that, I can explore. One of the questions that one of the kids, and I'm just modelling what happened in the class here, was because one of the different regions is actually homeschooled. And what they said, one of the questions that came up, well, if you were homeschooled, you'd have to have a cell phone. You couldn't exist without a mobile, like how could you live and be alive without a mobile if you weren't at school? So, okay, so they went, and now I'm going to see if I can find one of them, because there's not so many. Hawke's Bay, that's not what we want. Here we go, homeschool. So actually, this is the point to make here. When you click on one bit of data, then it changes to the piece of data. Okay, and you can put your own data in, etc. The interesting thing, I'll get to that in a minute. Jumping around, so I'll hold on to my homeschool while I've got her. And as I said, I just lost it, sorry. Shouldn't have talked, should I? I should just keep on going. No. It's a red one, and it's tucked in behind there somewhere. I'm going to have to give this a little whirl and line up. There we go. So, if I go back to cell phone, separate that, and then region, I should be able to much more. There's a homeschool. Sorry about that mucking around there. It was sitting in under a bit deeper than I thought. But there, so they were really surprised that no one actually, the homeschool had a mobile phone. So that throws up different questions. So they started to think, well, why is that? What's happening there? So from their perspective, from their worldview, if you were homeschooled, you'd have to have a mobile, because how would you keep your social networks going? But maybe there's some other socio-cultural influences which are changing the nature of why people choose to be, or parents maybe choose to be at homeschool. Maybe they have different ways of working, the different agendas. But anyway, you can see there that you can throw up questions very easy. It's dynamic. The bit that I started to interrupt myself with a little bit there is that it was interesting. There was UCL, they were doing quite a big project, a different one, and they actually used Tinkerplots, which is really a primary school to junior high school, because Fathom's a secondary, junior, freshman sort of a package. But they were using it to actually do their initial exploratory data of their big research projects. So just put all the data in, and then they could just have plays, really nice, interesting plays. So, you know, something for your dissertations later on. It might be a tool you can use. It used to be free, then it cost a lot. We tried to get it in every New Zealand school, and it was going to be hundreds of thousands. And now I got I think it was $20. I've got a lifetime license for it. So, and you can get school license. So it's one of those things, you know, when the technology at first is expensive, and then it changes over time. Okay, so I'll just come down to this again. And so some of the affordances, and these have been around for a while, but the interactive instantaneous feedback, that's quite an important one, I think, because it's that idea where you put something in and you get something in response. So what it does, of course, if you do that, is that you get some experimentation, and the use of real-life data becomes easier, because you can collect data and use it, you can input it. And the other thing around it that I think it facilitates is critical thinking. Now, I'm not sure where you are with critical thinking, but it's a really big part of our curriculum in New Zealand, and it's also, I mean, at all levels from early years right through to people doing their PhDs, critical thinking seems to be a key thing. In schools, they're looking at ideas like, I guess, compare and contrast, metacognition, those sorts of things, teasing those out a little bit. And I'm not pretending to be an expert in that area, but one of the things which we've found with digital technologies, which is important, is thinking fast, thinking slow. Okay, so especially these days when people, you know, kids are getting a lot more visual and dynamic representations, they tend to look at things quickly and then move on. We do ourselves, I think. I look at, you know, like if you compare reading a paper with a big editorial around something political or something like that, or a sports result, you might, you know, unpack it in more detail, but often now we just look on our phones, don't we? Just, oh yeah, and move on. So what I'm going to do is just put up a situation. I want you to just have a look at it, just come up with an answer. We're not going to share these and put it out there, and then we'll have a look at it slowly. So we're going to have a look at the fast version and then the slow. So just read it and come to a conclusion. Okay, so just you have some idea in your mind what was going there, what the solution was, or what the answer was. And now, so that's looking at it fast, and then we replay it again, so to the kids, right, think slow. Now, it could be that you've still got the same idea in your mind, being grad students. It's quite likely, but a lot of teachers just go, oh, I see now, you know. And for kids, it's even more so that idea of a half-life changes the nature. What they do is, of course, you're looking fast, you see the 48, you make a conclusion, 48 half. So that's how that works. And I think it's an important strategy. Putting that together with the instantaneous feedback comes to this idea that we've been teasing out, and I took the liberty of inventing a word myself, perturbances, but it's, you know, really a made-up term as well, but it seemed to work a little bit easier with the visual part. So this is an idea we explored. It came out of a couple of research projects. Another one was with 16 and 18-year-olds who had absolutely no qualifications. Some of them had been in prison, some of them, we call them reluctant learners, and they used some apps as part of their program, and it engaged them and got them going. So this is one of the findings that came from that, as well as the other projects. So this is the idea that attention evoked from the gap between the expected and the actual output. So you have in your mind an expectation of what's coming, and then maybe it's not the same. So, for instance, there's, you know, sequence you'll be very comfortable with 1, 4, 9, 16. You'll have in your mind where that's going, and yet it's that. Okay, so then we might carry on with that. And now I can see where the pattern is now. So that's where that changes. So you have an idea in your mind, but it's that. So it's that difference between what you're expecting and what actually comes. Okay, now this is another one, another visual example. So here's someone with a balloon full of water. Okay, it's absolutely chocker full of water. It's at the point of exploding. Okay, so this gentleman's going to come in. It's got a big pin. Pops the balloon, and I just want you in your mind just to have a little bit of a think about what might happen with that.
割ってみます。さっ。2000コマの映像、分かりやすく言うと時間を60倍以上に引き伸ばしたんです。
Okay, so again, there's possibly, not with all of you, but possibly I know with a lot of people they find that unexpected. They're thinking that in their mind the water's going to go everywhere, and it actually holds its shape perfectly. And so it might be, okay, well, so it might be in science, but what is the cause of that? Why is that happening that way? So it's something unexpected that creates, well, I guess a cognitive dissonance is an idea that's been around for a while, back in Piaget's days, but that sort of aspect. So it allows children to generate informal conjectures. You start to think, what's going on there? What's happening there? So from those informal conjectures, the mathematical reasoning can start to emerge and evolve. Okay, so the other thing, of course, around that is that the technology itself has enabled that to happen, hasn't it? Because you've got that high-speed camera, which wouldn't have been able to see that detail of it in the past. Okay, so I'd just like to touch base on a research project, one of the ones that we've been doing that, and we use this as a model, and I just want to TPACK model. Again, it's been around for a while, 2008. 2006, but although it's got weaknesses, and all models do, the point about it, why we used it, is because it does open up some opportunities, and I think that models do. I've had debates with colleagues who say a model should be exactly representational, but I think that if it opens up opportunities to explore ideas, and it can be an effective model. So you'll be very aware of that, even if you're not aware of TPACK, about the pedagogical content knowledge. Why we found it useful is because this is a different entity from just the accumulation of those two things. So you actually create something new, which takes a different type of development to come to. So you need experience in teaching really to develop that, whereas you can have content knowledge. If you've got content knowledge without the pedagogical knowledge, learning may not be optimized, and the other way around. Bringing in the technology allows this. So if you've got content knowledge and technological knowledge, but you don't have pedagogical knowledge, again, it may mean that the learning is not optimized, teaching as well. So NICE added in sort of a framework to this, which is what we use, because it was a research project with teachers, some with experience with digital technology or mobile technologies, and some without. And so we had 12 teachers, and we used them as co-researchers. So we use this as NICE's idea of this framework, recognising is that you actually see that, yes, with digital technologies, there could be some use for them. I can see that, yeah, there is a place for them. The accepting becomes, I'm persuaded by it. Okay, so more than just recognising opportunities, I can actually see it's an advantage, so I'm going to start using it, aren't I? Teachers are like that, I'm like that. If I see something that's got a use and a purpose, it's going to make something easier or make the learning better, then I'm going to try and bring it into my practice. The next one is the adapting level, and the adapting level is where you actually start changing the way you bring it into the classroom, but you also start adapting the technology. So you may change the way that it's used rather than just an app that is used. And we found that there was consumer apps, we called them, which is when you do something like it sets a game up, and you go down a little three-dimensional tunnel, and you shoot it as you go, and you score points, and you're learning around multiples or whatever, to what we called creative apps. And those are apps like the sort of explain everything, show me, those sort of ones where the kids have to create things. And we found that was much better for developing conceptual knowledge, where there was an element of creation, an element of investment in them, rather than just reacting to things. The exploring then becomes a stage where the teacher, because this is where the teacher is exploring different ways, and the advancing, the confirmation, is the element where, one, you're reviewing the practice, but the kids are self-reviewing as well. So they're actually reviewing what they're doing. Important part of this, and we found it very clearly with the research project, was it's not linear. It's not something where you go, oh, recognise boom, 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 you know, 1 week, 2 weeks, 3 weeks, a month, a year. This ebbs and flows, it's dynamic, as a lot of continuums are. In some situations, you might actually be doing advancing, might be working at that level. And then at other things, you might go back to sort of comfortable practice. Or you might think, actually, the best thing for that is to actually use some concrete materials. Okay, so these things are dynamic, and you move backwards and forwards. Teachers move backwards and forwards. Well, in our experience, they move backwards and forwards through them. Okay, so the methodology is interpretive. We had teacher co-researchers, 12 of them, and 3 researchers, including the research assistant. And what we did is we introduced some things, and they talked with each other and showed each other different apps. I'll share some of these soon. And then they hunted some down. So then we went in with videos and iPads and videoed up close, and we videoed what they were doing. And then we ran as researchers, picked out some, and they weren't exemplary practice. Some of them were practice where, you know, it exposed different things. So we had to build this nice inclusive culture at first, so people were comfortable with that. And we wouldn't show any video clip unless the teacher was, you know, knew what was coming. They weren't dropped into it. But then as a groups, we then reflected on that and came up with some themes, looked at practice. So over the 2 years, their practice changed. So there's 2 schools, one with a one-to-one iPad, and I'll show you a clip from that in a minute, and the other one was a BYOD, okay? As I say, from 5-year-olds to 11-year-olds, some of the teachers were very experienced in using digital technologies, and some were just starting it. So we try to get this big mixed, rich picture. And so that's how it worked. Now I want to show you a little clip, and I want you to think, how is the learning different to learning tables by rote or number strategies? So mainly in New Zealand we learn those basic facts by number strategies, you know, doubling, halving, you know, find ways of combining, tidy numbers, adding up to them, doubles, etc., etc. So we find ways of different number strategies. This is it's actually a problem solving app rather than a maths one. So what they've got there is you get a random grid, if you like, and a random number of basic facts. And they have to build up the grid so that it's completely full. So if they hit a snag, they can click on one of those and take it away, and they've got to restart. But the task is to actually make this completely full. Okay? Now this was a one-to-one iPad, and this particular teacher, at that stage, it was early on, said, well, the one thing I like about the one-to-one iPad is they just sit by themselves and they do it by themselves, you know. It's nice and quiet, and, you know, da-da-da-da-da-da. So this was just illustrating that that's not necessarily the case. So how is this different to learning by strategies, or, well, not strategies again, but number strategies?
Where do you want to go?
Which one are you looking for now?
2 times 8? I mean 2 times 9? Oh god, because I've done it. Wait, then touch it. So, I want to show it again. And then go across.
So that was someone the neighbours had joined together, and now the person in front had sort of turned around and come in. So it started off a really nice dialogue around that, but it also started off a dialogue with the teachers, because they sort of saw the opportunities with there, and we just actually ended up deciding that actually instead of a 1-to-1 iPad, it actually works best when it's like 1-to-3. It seems to be a good way to work it. The other thing, just to comment around that, that was what we call a low decile school. So the I guess socio-economic of the area was low, but what they did is they had a relationship with the company. The kids bought the iPads and they paid for it in an ongoing way, and then they had the right to buy it at the end at a cheap rate. So then that money was fed back into the next person who could. So they had quite a nice little system going with that. Okay, so emerging themes. These are some of the themes that will come out of through other things as well. The mathematical thinking is a critical thing, and that should be driving what we're doing. That's what underpins what we're trying to do, or the scientific thinking, or the computational thinking, or whatever your area is. And the social material assemblages became quite important too. So I'll unpack those a little bit more, but this was actually really interesting with the screencasting, because what was happening is some of the children were wanting to make things physically, and we just allowed them to do that. But then they would capture it in video with their iPads, and then they would incorporate that into their screencast. But they'd also have empty number lines, etc. on there, so they'd be explaining that. What it did was that it opened up their thinking. It made their thinking visible, and that was critical. And as I say, for you're probably the same here, we're quite multicultural in New Zealand, but we have a low tail with our Indigenous Māori students who sometimes struggle with their learning in areas like maths and science. And one of the reasons is about the language, because we're in bilingual classes. So one of my colleagues from Auckland University, when I did the presentation, leapt on this idea because she's working in that area, and she said this is opening up huge opportunities for them to screencast their thinking, but they can use a mixture of physical, recorded materials, they can use their own symbols, their own language. So she has done some work in that area, which I think is really, really, really going to be beneficial, and we're sort of working on some things there. The social material assemblages, the collaboration I talked about. We've got, sometimes people put these together, we found that they're really related. The personalisation is that personalising of your space, like we do with our phones, and we've got our own apps, and you might be your screensaver, etc. But also the differentiation is often seen very clearly as just a teacher designating a learning trajectory based on their understanding of the child. But what we've started to see that these were merging, that students were making their own decisions around how they differentiated the learning. They were evaluating where they were at and making decisions, okay? But they were still personalising as well. So a couple of things going on with that. And then that led to engagement, motivation, risk-taking, which I think is really such an important thing of actually learning. We forget that creative element is much more in the discussion now, but risk-taking I think is really important. Not risky risk-taking, but in a way that you'll try something and then be happy to move on and say it's not working. So this is a little bit of student data. I don't like putting up screeds of PowerPoints of these, but particularly that multiplier app and hopscotch. Hopscotch is a programming. We've got coding as a compulsory part of our year one, which is our 5-year-olds to 12-year-olds curriculum from next year. Okay, so it's part of the information technology curriculum. And this class was using hopscotch, and they were programming Pharaohs. Pharaohs, the little robots. So it's a little bit like the logo, but you program them to move, and they use, I won't go into too much, but they're using robotics anyway, using an app to program the robotics and make it move. So hopscotch is a big hit, as you can see your creations moving around. So this was that interaction again, and I love this one. There's got to be a chapter title there somewhere, and it's just like making a movie for maths. Now, isn't that lovely to think, kids, I'm making a movie for maths, woohoo! I just sort of went, yes! I thought that was very cool. I don't often think I'm making a movie for maths, Okay, so the other thing around those, just touching on again, you'll see there's some new ones in there which we found, the visual and the oral have been there, but this haptic then became important. And with mobile technologies, it's just because you can move on your screen. And that's what the haptic is. You can move and play, you can shape and move. So it brings in another element to the reading, to the learning, And we'll mention Natalie Sinclair there. Her and Liz DeFreitas have written a book on mathematics and the body, and that's around body cognition, and there's a lot of work around gestures, so a diagram is actually a snapshot of a gesture that we've made as we're drawing. Okay, so there's stuff around that, so I won't go into it too long, but you maybe open up some ideas for you to explore a bit further. So focus constraints. So this is some colleagues from Utah University. They did all the digital learning object stuff, the virtual learning objects. You may have seen them online, and they turned them into apps. And these are some of the work they did around focus constraint, so you can focus in on the content more. So these are a rewording of some other things, other affordances we've talked about. Evoke a range of approaches and solutions. So this is a creative bit. So by using digital technologies, you open up the ways that you can do it, especially with those, as I said, explain me, those sort of mass shape, those sort of ones. Simultaneous linking. This was a little bit different because normally it's been this linking representation simultaneously, and people like John Mason talk around that about seeing the general through the specific. So seeing different representations and being able to move between them allows you to move from those specific things, instances, to make a generalisation, which is, I guess, an important part of algebraic thinking too. But also allowed you to link them to student activities. So there's some nice work in Cabri geometry where students develop algebraic thinking by using geometry, which is very much, we tend to use, I think you do too, numerical generalizations to get to algebra, but they use geometric generalizations to get to algebraic thinking. So it's a different way of working, but they could link what the students were doing with their hands to make these shapes to them then generalizing, and that was their algebraic thinking, the way they were developing it. Okay, so moving on to this social material, this other assemblages, this is another theme that came through. And we looked at this assemblage theory that DeLand, and DeLand is actually an architect, and it's quite a nice starting point because, we think of architecture as being a building as part of a community of buildings, isn't it? But we also think within that building, how do people move, how do they interact within there? How do they communicate with each other, how do they work there, how do they move around the building? But also, very importantly, not just the buildings and their relationship, but the people's relationship with each other within the building. Okay, so that was the idea that the social complexity emerges more than just the interaction, it's more than just the parts, it makes something new. Okay, so this is another idea related to that. I've did quite a bit of work with Marcel Borba, who's from Brazil, but this is an idea they've been exploring for a while. So it's re-engagements with collectors of learners, media and environmental aspects. This being digital media, but it can be any media, with phenomena. And so it's that idea that you change your perspective and then you interact from a fresh perspective. Okay, and then Mayer's this idea of offering social material bricolage for learning. So the bricolage, if you're not aware of that, it's a French term which means you take a little bit of this and a little bit of that. So it's actually not used, they use it more on things like cooking and gardening and things like that, but it's quite a nice thing if you're working in digital technology. You don't just run through the app and run it out. You actually take a little bit from here, put it together and assemble things. So that's what we're finding that the students were doing and the teachers were doing. Okay, so the idea of that, this is some kids doing some science. You can see they've got some material objects, they've got some digital objects. What they're doing, I'll just run it through there. They've got a sensor there which is measuring the CO2, carbon dioxide that's in that enclosure, and then that closure. And then that links by Bluetooth. They've got it to their laptop, but others have got it to their phone. So some groups are using their phone. And some. So that was just to illustrate the idea of these assemblages can be more than just a social in terms of collaborative thinking or critical thinking. So it can be a range of different materials, and obviously that's in the respiration of your cycle when you look at that in terms of where the graph is going, the CO2 is going. Okay, so some assemblies could facilitate, risk-taking, investigative approach. collaborative approaches, engagement, seeing connections, alternative learning trajectories. So that's what we found, that's what the teachers reported and what we were seeing. Okay, I'd just like to show you some apps now. I'll just switch over again, sorry, but so these are some apps that we use in the project, but also in some here we go. Alright, so this first one here is Sketch Explorer, and this is a nice one. Talking about that interactive one, this is an open source, so it's free. Just nice, brings in that haptic, so you can draw a shape and it's replicated. The nice thing is around that, so you can see what's transients, but of course you know in geometry, it's not what varies which counts, but what's invariable which becomes interesting. So they can, after a while with exploring, see what are the points that become invariant. Okay? And of course the risk taking, you can just get rid of it if it's not working out for you, and try something again. What's varying, but what's staying the same, and what does that mean? Okay? This is a nice little one, mirror. They can put in their own photo, of course, but this one's already in there. But it's one of those ones that you can, like the house of mirrors sort of thing, and you can get all sorts of funny bits and pieces going. But the kids love playing with this, particularly when it's their own photo in there. Triangle angles. So again, exploring the dynamic bit, exploring different angles, and then you start to explore things like right angle triangles. What does that mean? What does happen to the other elements? This is a fractional one. It's using the pizza model of fractions, if you like, which has got some limitations. We've been trying to use groups, but it's quite nice that you can vary the size, etc. And with this, one of the things I do like about this, though, is that you can put in 10, and it shows mixed numbers. There's a mixture of wholes and parts, so that's quite a nice aspect of that one. Decimals and place value. This is quite a nice one. So you might take an estimate, get the kids. It's about 2.3 maybe, and then it zooms in, and actually it's a little bit less than 2.3. Maybe it's 2.28. Actually, it's a little bit more than 2.8. Maybe it's 2.87. And you've got two other layers there. You can see where you can go and how you can do it. You can use that as a class tool. It's quite nice because kids don't actually see those connections between those. But you can use it as the kids exploring by themselves too. Okay, and then there's some common multiple ones. That's 3s and 4s. Logical reasoning. This is that game where under the X is a number and you've got to say, I put it there, is it above that or is it less than that? Is it, that sort of thing. So a little bit of logical reasoning. And then volume of boxes where you can change the volume, and you can then, again, you can explore that in different ways rather than just move the thing, otherwise it doesn't mean anything. But if you were making a box and explored the volume and what that meant, and then unpacked it, and then, how would I make a box which is half the volume? An interesting one with kids. First of all, they think, I'll halve the size. It's interesting. Okay, so just a couple more there. That's that one there. Place value. This is quite nice. It's very simple, but it's nice because you can take 100, 300s, 610s. Sorry, I'm pointing at my iPad and you don't know what I'm pointing at. And I can move that to there and I get 10 10s. And then I might take a 10 over to the ones and I can get 10 ones. But I can put it back again too. So I've got 11 ones and 15 10s. And put it back, but I can also just add in individual ones. So quite a nice little, again, not directed, it's open for exploring and making. And this one's touch counts. You may have already been showing this. It's got 2 phases. It's got an oral one too, which is quite nice, but it can count, and you've got a ledge you can count numbers through. But you can also make numbers, which is quite cool. You might make a number sequence.
5, 3, 5.
Oh, not that one. I lost that somehow. Okay, but then you can pose questions like make 6s. So how many? So you might make them in order, but how can I make 6s? Oh, okay. I can put 5 and 1 together, and you can see that it keeps the colours still. I love the little thicks too. Someone who had a lisp when they were young. That's quite neat. Oh, a double there. Now this is not, I need a 1 to make that into a 6.
6.
Okay, so etc, etc. But I can then also unpack, so I can
1.
I can subtract. What's 6 take away 3? And I can do this with any number. So you can see it's lit up as white, so that's 6 take away 3 white ones.
3.
I get 3. So nice. First time I always give children things to sort of explore and have a play with. Of course, they just want to make the biggest number they could, you know. 3 hands going on, and then they start being a little bit more actually thinking. Okay, let's get rid of that one. I just want to see if there's anything. Oh, the other one I'll just put up there is Desmos. And Desmos is a higher level, tertiary level one. It's a function plotter really, but you know, you can look at intersection of you know, hyperbola and not hyperbola, parabola and a line, straight line. You can vary that. It's a little bit messy at the moment because you can only really show one at a time, and I did want to show you that function which has got that nice cool design on it. But the nice thing around that too is that, you know, I mean, I've got it on my phone as well as a few other apps. You just have it on your phone, so you can do your function plotting on your phone. I think I'll leave that there. There's a few other ones there if you wanted to have a look at now. That comes out and that goes in. You're welcome to have a look afterwards, just to have a little bit of a look. I'll just come back to my spot. Okay, so that was Sketch Explorer. Those are those other ones. GeoGebra with Desmos, Scratch and Scratch Maths. YouTube is another thing. Now, we found with an inquiry learning with secondary schools, they were in groups of 4 and they had to come up with their own, it's quite project-based learning, I suppose. They had to come up with their own environmental problem or a problem about a leadership or something like that, their own question to investigate. But YouTube can also be for them to go and find out clips. So they could find out themselves about, in that particular instance, they were using it to find out, say, how to do a box and whisker or etc. to explore things. But you can also use YouTube, can be a nice thing to actually introduce something. And
so today I want to talk about the Mandelbrot set. But I want to, so there's so many videos and websites and Java applets and all of these things where you can see the beauty of the Mandelbrot set and this really nice fractal picture, and you can zoom in and see all the interesting things. What I want to talk about is, what is this object? So what is the picture a picture of? Why do we care about this picture other than just its intrinsic sort of appeal? And so just to generally talk about the way that maybe the mathematicians will look at the Mandelbrot set. The first thing we need to understand is that this entire thing is happening in the world of complex numbers. Okay, so if you remember complex numbers, or the complex plane, the way that we view this is that we have 2 axes, and we plot on this plane numbers of the form, say, a plus bi. And here, these 2 things are real numbers. And I is a symbol that means that I squared is equal to -1.
okay, so the idea there is that you might introduce something in a different way. It might be more appealing, and it might, again, that visual aspect of, okay, what's going on here? How do I make sense of it? And that actually is really, I like that picture. I wonder how that's related to complex numbers, rather than, you know, I used to teach it, you know, like, these are complex numbers, here's a few exercises. I mean, you know, that was a long time back in the day. But this is another one, Blipper. Okay, so this is augmented reality. Okay, so this is some colleagues, actually there's a chapter of that in the book, and Dawn's got a chapter, a really interesting chapter in there as well. I've only got that, it's not really supposed to be hard sold, but I just picked it up in Copenhagen. It's just been released, and it's why Dawn hasn't got his copy yet, but it's on its way. But this is an idea of augmented reality. So students are going out collecting data, so this is London Eye, you'll be aware of. Okay, so they take a photo, and you can take a video clip too, in their camera on the hoof, on the go, and then you can see they've put a mathematical model to situate through Blipper on top of their shot, their photo. Okay, so then they can pose a question like, how does the height of the capsule vary as the wheel rotates? Okay, so nice little inquiry. This is for junior high, what we call, 14 to 15-year-olds, I think it is. Okay, so how does it vary? And then they can graph it. There's a whole lot of other bits and pieces till they get to that. But then they can graph it and see what is happening with it as the height changes. Okay, so that's augmented reality. This is virtual reality, a little bit of explore of that. And this is exploring the visual tradition. So this is just outlined. So we've got 360-degree video now. Using that with immersive video allows us to get some virtual reality. These two ideas are important. The immersion is, that we can actually take students to places, and it might be with, I know in Australia they've got a lab where they're using it for medical students, where they can actually go inside veins, more than not just see them virtually and operate, but actually can go inside and they feel like they're actually in there, and so they can look for, say abscesses or look for cancers and things like that. So changing the nature of how we might learn things. You can imagine with school kids being able to take them, from a city environment in New York, to take them to somewhere like the Great Barrier Reef in Australia and actually in the water swimming with them, or out into space, so you explore. Marcus, that student I was talking about, he's been bringing dinosaurs into the classroom through virtual reality. So that's something early years students don't normally have as part of their program. So, and they actually move and duck, even though you're only supposed to use your eyes. So we can represent experiences in different forms of this, but the manipulation part is the part where you can be inside other people's perspectives. And with that, so you can, be as somebody else, I guess like an avatar or something, experiencing what they're experiencing, so that opens up your perspectives, but also you can look at yourself as you would react in different situations. So that comes to a reflection, doesn't it? It changes that whole nature of what is the reality and the narratives that we have around our experiences. Okay, so we're very early stages of exploring what this means, and that going back to the question, what opportunities do we gain, but what do we lose, is something which is still a long way ahead there. This is the idea that it's a latest evolutionary stage in Western pictorial tradition, starting from drawing in sand, boom, 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 printed press, etc., etc. Immersive videos of a visual tradition that is a form of virtual reality. Okay, I'll just duck out of that very quick. I'm just going through this a little bit fast now, but I do want to show you this. So here's some science using virtual reality. Okay, so just a nice little clip how it might change the nature of how we, teach science or teach other things. But here's a student. Sorry. How we overlaid showed several different views. So, and this, the kit is getting cheaper. It's not like this is, a one-off $1,000. It's a bit like, phones. They used to be really expensive, and now, you get this really cheap. Although they keep bringing out new models that you think you've got to buy. That's but you can see this sort of kit is actually getting a lot easier. I mean, that's just in one context, but you can see how that might change, how we learn things. The opportunity. I mean, as I said, maybe there are things that get lost, but I think there's a massive amount of really important things which can add to the learning, can't it? Okay, I'll just flick through these last ones now very quickly. Oh, I'm going back to the same one, sorry. Oh, no, I'll go back to that one because I think that's important. One of the things that came through is that the pedagogical approach is important. And I like this even though it's 3 years old now. Technology can amplify great teaching, but great technology cannot replace poor teaching. So that interface between, the pedagogy and the way that you approach things is critical. This rhizomatic networks, this is the idea that, mainly with our models up till now, especially, have been hierarchical, but a rhizome is a biological entity where, like a potato or something like that, where it's connected through, in different ways. The nodes get connected. So the ways that interaction happens in different ways. So mathematical modelling of real life contexts. So as I mentioned with the augmented reality, that's a way to bring the real life into or on the move. But what opportunities are in the following? So here's a situation which is also maybe got a little bit of visual expectation. So I'm showing this because with this and with entertainment, you know, in our children in our class are looking at things in a lot more interesting. Oh, push the wrong one. They're looking at a lot more interesting material. So how might you use this to motivate? What's the mathematical learning there, or what questions might arise? Mathematical questions or another area. Again. Is she quite big?
Is that you?
Nope. So again, how might we use video clips and these things which are open on YouTube and a lot of variety? How might we use them as part of a learning progress? One of our colleagues in England at another institute I was at said they woke up after seeing this and they woke up in the middle of the night having dreams of being that surfer. She said, I'm only a woman of about 65, so I'm thinking, that's it's opened up new opportunities for her. Okay, so the other thing is around digital cities. This is something which is much more pervasive in our ways of thinking about the world. I mean, there's, I guess, political dimensions to that which we should be troubling as well. But, there's efficiencies as well, that the way things, we're saying in airports now in New Zealand, it might be that you don't have passports, you just walk into the airport. By the time you get to the check-in counter, you're already checked in. But there's also very important, I think, environmental aspects to this. Really very important environmental questions we need to think about. So it takes 2,700 litres of water to produce one T-shirt. So lots of sort of mass which you might tease out of that. Because, I mean, at the moment, if you think of resources, water is probably going to be the next oil. Take 20,000 litres of water to produce 1 kilogram of cotton. Make a single T-shirt and a pair of jeans. Each year, over 2 billion T-shirts are sold. Quite scary, isn't it, when you look at the numbers and how that might work when you scale them out. I mean, it's a mass that's straight in there, but how will mobile technologies and digital technologies help us answer those sorts of questions? And then, of course, there's environmental elements too, isn't there? So, what does that mean in terms of dye going into our water system? Can we use mass and can we use digital technologies to help solve these major problems? Can it be used to help solve those big reservoirs of plastic in the middle of the Pacific? Between here and Hawaii, I think there's one of the worst ones actually. Okay, so just to sum up, mobile technologies, social material assemblage to reshape the learning. They model real life problems in situ. Collaborative problem solving is something that was very strong through the research projects. However, the pedagogical approach is critical. That's a key thing. You can't just have a good app and give it to kids. It's the way that you use it which is a critical aspect. And mobile technologies can transform the learning, but they can't do everything, of course. And I really like this cartoon. Your X-ray showed a broken rib, but we fixed it with Photoshop. Oh dear. So, thanks everybody, and welcome to take any questions or queries, or if you want to have a look at some of those other apps here, then feel free to as well. Yes.
I'm not sure I understood the activity of the pad where they were trying to change colors of squares? I know there's a 2x9 activity, but were they just trying to find some pattern of 2 squares by 9? I didn't understand how the color interacted with what they were trying to do on the screen there.
I guess the colour was sort of a coding, a visual mechanism, but what they were trying to do was, like in multiplication, often is just used, like repeated addition, so it's getting to an idea of a matrix, so that's got different properties. So they drag out the matrix, so it's, I didn't explain it very well, sorry. If it's 5 by 3, they have to make a 5 by 3, they have to drag it out and see the area of that, and then they relate that to the basic fact. So what they were trying to do was get the 2 by 9, but it wouldn't work because there was no space left for it. So it was just illustrating how they were negotiating where they were going to go from there, the sort of collaborative part of that, But
For the puzzle, you had to fill the whole area with those resources.
So were they trying to make an entire square, or just that irregular pattern they were trying to fill?
that irregular one. So the app generates different irregular ones,
Gotcha.
and they've got to fill it exactly with the number facts on the left. Those number facts will fill it exactly, not one square more or less.
And the gray squares are ones that haven't been assigned yet? Is that right?
Yes, that's
I
right.
see. So they're trying to find a 2x9 pattern of gray that hadn't yet been colored.
That's right, yeah. And they got quite sophisticated with it in the end. It was quite difficult at that early stage, but then they could start to see how the shapes work together and how the importance of it, so Sorry, it's one of those ones you need to have a little bit of a it doesn't transpose so easy to...
The other ones I got, that one I was...
Yes, sorry.
Would you mind talking more about kind of technical knowledge barriers from like teachers and students maybe who were involved in some of this work, and like what things were sort of helpful in helping teachers kind of move past those kind of barriers of technical knowledge?
I think the technological barriers, one of the key things was developing a community of practice, so where they could interact, and you sort of had, I guess, shining lights within those who would pick up things, but again, it needed to be quite informal and have a high degree of trust, because otherwise people can feel isolated. I'm not going to try that. I don't want to. But if they do it in a sort of a collaborative space, then they're more likely to take a risk. And if that is supportive, and somebody says, "Oh, try this. This worked with me," then that really helps get through some of those barriers. I think also you need to have in tandem the technological understanding growing as well as the mathematical and the social growing. Like those things need to be interrelated. It's a really good question actually, because it's the interesting thing too. It can be dispositions, I think. One of the other researchers said, "I know what's going to happen here. All the young ones are going to be into this boots and all, and it's going to be the old ones that we're going to have difficulty with." But it wasn't the case. One of the older teachers was just really creative and did some amazing things. And it started the journey young. And one of the young ones was quite hesitant about it and quite nervous about it, and was comfortable on their phone, but was the risk taking with the learning was what was concerning her about it. So no silver bullet with that one though. But the community seemed to really help. Yes.
I'm curious to listen to your opinion towards online classroom and the idea of flipped classroom and its implementation in not just K-12 but also higher education institutions. Have you done any research around those?
I haven't done any myself, but I've used that approach. Well, I use it with I teach research methods for master's students as well. And I have a face-to-face class, and then I have an online class. So we put up Panopto videos and try to be not confrontational, but try and be provocative with what we put up. So what that then becomes is the flipped classroom aspect is, I guess, in a way, it's flipped classroom is that they have the resources there, they interact with them in their own time. And then there's an online discussion around that, or we have online forums and what have you. So it just means that those forums are more focused on an activity. I think again, it's around the opportunities that it gives and the constraints that go with that. So some people, it opens up opportunities for people who are isolated or busy teachers, and they can do it in their own time. And it opens up different types of discussions and interaction with resources. But some of them say, and I normally with that class, I give an opportunity to have a Skype meeting of I've got students all around the world on that particular one. But even if they're 20 k's away, sometimes they can't get into a meeting, so it might Skype. But I'll also have a face-to-face session as well. So I think it's opportunities and constraints there as well, and very individual. Some people dislike that social interaction because it mediates their ideas. Other people like the online forum because they can actually research in the background and then put it up, and then you get 30 minutes to look at it and change it a little bit and think about it. Whereas they may not stand up and say something spontaneously in class. They're a bit, I don't quite want to put it out there, but if I can put it out digitally and have a think about it, then so it's a little bit opportunities and constraints, but it can be very dependent on the person and the way you do it too. I think I'm still learning in that space, but I'm finding ways to provoke people to respond and be inclusive. Like, has anyone done this? Can tell us about what you've been doing in this space, but not make it too hard, so people can say, oh yeah, I've done this and this, and then I think it's a good way to go. But do you have any online courses here that are you involved with, or?
No, I'm just curious. There are a lot of companies, and some of them are career oriented. Some of them are like university courses, like Coursera. And I'm just curious. The thing is, what they try to do is to provide access to all learners around the world. But then in practice, they encounter many barriers. So just.
Are you talking about MOOCs here?
MOOCs is a big part of, and like Khan Academy.
Yeah,
big.
That's right. Khan Academy is quite used quite a lot in our schools in terms of pushing students towards doing their own tutorial work, I guess. But I think you're right that there's a lot more opportunity, but there's questions around that. I think it's probably a rich area to do some research in. I've had a couple of master's students do that for their dissertation. I haven't had anyone with a PhD do it, but I think it would be a really nice area to explore. I've been a little bit too busy in slightly different areas, but
Thank you.
I'd like to. Yeah, good question.
Thanks for that very interesting talk. I'm sure you've been asked this question many times, and because policymakers need to make decisions about where taxpayer money is going, and following up on the earlier question, adopting these technologies often means a big expenditure, a lot of overhead into professional development, etc. So how, and therefore often we see these papers comparing concrete and digital, manipulative, that kind of thing. What is your sort of top 3 selling points for why a teacher may adopt these kinds of apps? As an example, a teacher might say, oh, I've got those good old wood, colorful geometrical forms, the squares, the rectangles, the rhombi, and all of those. And kids can be explorative, they can take risks, they can solve problems, they get feedback, they can, etc. So what are your things? But they can't do this, this, and that. What are your thing 1, thing 2, and thing 3?
Well, I guess the first one is they can explore things which wouldn't be available to them otherwise necessarily. So if, for instance, you say, with geometric software, you can actually pull out shapes and make them and manipulate them. So rather than draw or invest in drawing something, and the same with graphing, if you draw and invest in something, then you're less likely to take a risk because you've made that change and you've done it, and it's become, becomes significant and becomes signified through that diagram. But with a dynamic world, you can move things and shift. You can try things very easily. So that risk-taking, I think, even though you said it's part of it, is much more open and obvious in a dynamic world. The other one, I think, is that multi-representations, where you can see things at the same time changing. So I use that very quick example of, like having a graph of something, having a table of numeric values, and say having a symbolic formula. And if I change one of those things, bing, 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 the other things change at the same time. But you can also, in terms of that, with the tinker plots, where you can explore. I mean, you imagine taking that data and trying to explore different questions really easy, and then just go rearranging, and then you can't do that physically. You can, but it just takes a lot of time. We had a little one project where the students had to, when you divide a number by one, by some numbers, you get a recurring number, and when you divide one by some numbers, you get a discrete number. So which ones give you, recurring, and which don't? And so we did that with 10-year-olds, 9 and 10-year-olds. Now they explored like about 5,000 different examples and came up with the generalisation, because they did it in a number or like a spreadsheet, and they could just pull down, and then they could just drag it up inside, do a graph, and have a look at it. Okay, so those sorts of explorations, you just couldn't do that. Well, you could, but you can imagine with a 9 and 10-year-olds doing 5,000 and working out, you get to about 3 or 4 and I'm over this, So it opens up opportunities there, which I think are really important. And I think the other thing, which is probably a third one, is it can be very motivational. So some students who get really bored and are not engaged, and it's been a traditional thing in mathematics across many contexts and countries. For us who enjoy maths or have success with it, we engage with it, we like it, But there's, 30%, 40% of the world who hate maths. There's maths phobia who are, so as I said, with those reluctant learners, it actually turned around because they could play with stuff, they could see it visually, it was tactile, and which I know you can say with equipment, but a lot of older students, like at high school, unfortunately see that playing with equipment as being what you do in primary school, what do you call elementary school, and they're reluctant to do that, but they're not reluctant to engage with it in the digital world. Okay, so it's motivational, so that's probably the third thing.
I believe our time's up, so thank you so much, Nigel. Enjoy the rest of your stay.
Yeah. I'm heading down to Santa Cruz to have a little bit there, so that'll be